You have online class on Monday. So on Monday we have online class. If you have, some places are finding it difficult with several courses. Even if it is physics, forget that they are teaching you and you are shouting, yes sir. Do you understand? Yes, everybody will shout. Some places are finding, some places are so sharp. If you know, if you are typing up with your phone, you will not feel shy. Type that message. Chat the. One guy brought a textbook to me now. And he was asking me about the organizer. This one, I was actually explaining things to you. That kind of a thing, if you feel like you are confused, if you are not grabbing anything, that's why you do leave a number as much as so that you call, you chat, sir. This thing that you say, either even if you want to correct, not correct in the class, it's very bad. Yeah. Upper CP is not my ICT. So it's very well. You can actually call the person out or chat with them. It's not you, like, it's not about you. It can happen any other place, like in your church, or in your fellowship, or your gathering. Like somebody made a mistake. It's you, everybody will start laughing. Hey, very bad. So if you want to correct the person, or not, just correct me. There is one girl, I don't know if Favor, she was asking some questions in our previous online class. What is this? Some person said that the questions are stupid questions. But they are not stupid questions. Actually, doing the same. So whenever you are confused about anything, ask, don't cease to ask, always ask questions. And number one, nothing to do. If they should teach you to be good, come back and ask questions. Am I making any sense?
First class product of ABB. So when you advise you to take it.
Yes.
And most of you don't know that everybody teaching you here is a first class product. And then sometimes when they are teaching you, you think maybe we are just going to know your computer thing. Don't worry, as you grow in the department, maybe when you get to your 200 level, 300 level, you start to know people in different levels will be telling you, okay, I know this person finished from my department, this one, those stories will make more sense that way. That's why we don't come to start telling you all those things. Alright, so please. So please, let's start our physics class. Yeah? Please, because of our time, I want you to open your physics workbook. What begin with your physics manual too?
Have you chatted before?
There are certain questions that are please, let's go with your physics manual. And today's one, we're not going to be spending so much time, so we cover everything. Please, open your manual to page 130, 130 and 131. Do that question for me. For physics workbook. Something about group. You want to kill my guys? On top of my mouth, how are you? Alright, so please go to the question 130 and 131. Try and do something. There. Guys, I want us to solve from 130 to the last page of that. Yes. So 130 and 131. And I start doing it. You can see what we do. So that it will help us for those of us that are read the question out to any write it on the board. And read the question out. What is this material in your car? What is it? What is what? What is the instantaneous? instantaneous speed of a car.
Moving according to the equation.
You said?
Moving according to the
Moving according to
equation.
okay, according to the equation. Yes. Yes, why I want us to do this question, I know it's usually we are the one that met me the other day about questions like this. And we go back and make sure what we're doing today. That's why we're starting from there. Moving according to the question,
X equals to bracket.
X equals to
2x cubed. 2x. That's the bracket.
wait, X equals to
2 brackets.
2t cubed
Plus 40.
plus 40 squared. You see well, what we get to find? 110. Like this, Jimmy?
At T equals 4
At T equals 4 seconds. Do you know why I like students of this hall? Why I like students of this hall, should I say this year level, is that even when people see God, people still stay and maintain your calm. Yes. It shows that you people have that maturity before coming in. Yes. So please, have it in mind that. Okay, so please. So try and look at this question. That's 130. Then 131. That's the two questions. Like I need 131 out.
A projector runs at 45 degrees.
A projector launch at
45 degrees.
45 degrees,
With velocity of 100 meters per second.
with velocity of 100 meters per second,
Hit the target.
it's a target.
What will be the velocity if you bring on board?
What will be the velocity if the range is double? Alright, please make sure you're doing something. Make sure yes, fine. Do something and hold on the back. So once your people come back, I thought you're blocking. I think so. But I'm not sure they will solve it together. You want that? You want that? Correct. If you are doing signal, where is your friend? Where is that medicine student? You went to. So once you are coming for Saturday class, you should eat food well. So that you have the stomach to stay till the finish class. It's not for the weak, but for the John week. Yes. If you are doing a signal, let me come and check. I'm coming. Yes. Right, second one. Correct. Second one. Okay, somebody calls me. I work with the person. So I'm waiting for your answer. But you saw that's his answer. Now, come. Okay, take it.
Yes. Who else for the passes? Yes, who else for the passes?
It's not complete. It's remaining. I continue from there. It's still continue. You still have steps to go. The steps to go. It's maximum rate. There's something like maximum rate. Make sure you're doing something. Next your work. Correct. Boys are not smiling. Everybody's getting it. You are missing something. But see, hello. Pay attention. Let's start with this. Let's take it one step at a time. So please watch. If you come out to the pay attention, so you see you can get it. Pay attention. Then stand. What is the instantaneous speed of a car? And I have told you before that even if they tell you instantaneous speed or whatever they tell you, you will not be instantaneous. and focus on what they are talking about, which is speed, Jimmy. And we say that speed is essential with velocity, is it not good? But notice that anytime they give you x means distance, is it not good? Hope you know that x means distance, while s means displacement. Are you aware? It's important. And displacement and distance, they are the same thing. So what I will do is to ask myself, do you remember that our equation? Do you remember that velocity is the same thing as saying the derivative, change in s, shall we? All of the change in t. Is it not good? This change is the same as saying s over dt. But here is x they are talking about, so this is the same as saying x over dt. If you don't want to remember English code, you can say, I once taught you that if I have distance, and I have velocity, and I have acceleration, I once told you that if you are moving from this part to this one, you will do what you differentiate, is it not good? And you differentiate once. And if you are moving from here to here, you differentiate. So, assuming I'm moving from this point to this point, I will do differentiate 1, differentiate 2. But since it's velocity they are asking which is speed. I'll just differentiate 1. So I'll say all this is given to me. Then we differentiate it. And by differentiation, I'll simply call it now velocity. Since it's the differentiation I want to call, that's the velocity is equals to dx with respect to dt, which is the same as saying v is equals to. So I have 2t raised to the power 3, which is the same as saying 3 times 2. Then t raised to the power 3 minus 1 plus that 4 is having t raised to the power 2. So I will say 2 times 4. Then t raised to the power 2 minus 1. This is what differentiation is all about. We have a x raised to the power 2. This is the same as saying multiply the coefficient to the power, which is 2a, then subtract 1 from the power. Yes. So if I know this, I will now use that same concept to continue. So I will say plus. Then that 1 times z is having anything like a variable here has a power, raised to power 1. Is it not true? So I will say plus 1 times 1 10. Then 0 raised to power 1 minus 1. Are you seeing it? Yes. So the next step, this is going to be same as saying what? V is equal to what? Plus 1, which is the same as t. Is it not true? Then plus 1 1 0, because t 1 minus 1 is 0, should be? And anything, for example, a raised to power 0 is what? 1. So 1 times is the same. So I don't do that. Now remember they said there is a time that we should find this velocity at time 4 seconds. So when I say at t equals to 4 seconds, it simply means I will substitute. Is that what you used to do that your function those days? So I have v is equals to 6. Area is still 4, I put 4. So plus 8 into 4, then plus 1 1 0. So 4 square is what? So this is 16, then plus 8 into 4 plus 1 1 0. Well, add up what, multiply and add up what you have. So v is equals to 2 meter per second. Very simple. Alright, let's try to look at 131. That's because we will not start the class with us. I will put you. But when the velocity differentiates, when this one watch. So this is distance. When we started class, when we started kinematics or kinematics, my friend, the year, sometimes thoughts and different things happening to you at a particular moment, you want to make it a non-pay attention. Just live the enduring. Everything will be fine. Alright. I said when we started this class of kinematics or kinematics, I said that we have distance and displacement. And I said distance and displacement they are the same thing. Just that distance does not have direction. Why displacement and direction? For example, if I come and say A, you don't know from if it's A, I'm moving to B, I'm moving. But if I come and put an arrow like this, you know I'm moving from B to A. Is it not good? Yes. So if that is the case, once I'm talking about direction, I'm talking about displacement. That's the first thing. Now I said that velocity is the same thing with speed. Just that speed does not have a direction. It deals with distance. So should rate of distance. That's the distance of time. What velocity deals with direction. Now I said that the mathematical of what is acceleration. And I said that even from the definition, velocity is change of displacement with time. Speed is change of distance with time. So it simply means that if I am giving a question with distance, if it's moving to velocity, if I'm converting to velocity, I have to differentiate once. So if let's say they gave me something in x as an equation, so if I wanted this to get to velocity, I will differentiate it once. So I now said, moving from this point to velocity, I will do differentiation once. But if I'm moving from here to this part, notice that I have to differentiate twice because acceleration is changing velocity in time. And changing velocity itself is changing in this. So it means that from displacement to acceleration, I will differentiate twice. I now said, if you are not in the other way, or on the other hand, they give you acceleration and they want you to find value of displacement. Now moving from this end to this end requires integration. So if I'm moving from acceleration to displacement, I will, first of all, down here, up to this point, I will integrate once. Now if I move here, I will integrate twice. So that's what I said. So it's not confusing. So if you know it, even you can deduct it from the definition. If you are not doing differentiation, what you should do is integration. Yes. So with that said, let's look at 131. Can I clean? But I can do the question. Check their notes. We are going to be starting batch A, batch B class from Tuesday. So that by January, we'll not start batch C class. And that batch C will just be people usually in January. Batch B, batch A simply means if we started school October, from October 14th, that's school resumes. All through October, you have your own class, that is group A class, batch A class. Why batch B are those people that started November, mid-November, then December. That's batch B, so that we can start from the beginning for the batch B students. Why those of you that don't want to join us, can stay in batch A? That's what we mean by that. And see now, in fact, January total, we'll just have batch A class together and then batch C, that is starting afresh. Batch C. That's how we normally do it. So please, if you hear batch A, just you now, you check where you belong. Know where you are coming from, or which class you are coming from. Okay, see, I want to try this and I saw what most of you did on this. For me, I want to try an approach to see if it will work. So we'll try two methods. Your method, that method I gave you an answer, my own method, you should give us the same answer. But let's check it. Let's talk about, yes. But let's try your own method first. I have range is equals to u square sine 2 theta all over g, Chevy. Now, if you don't know how to derive this, check our notes on kinematics in 2 dimensions. On Tuesday, we'll start from the beginning. We'll take that how to derive this. What I was simply say to myself is that abandon everything I'm seeing here. Let me just deal with this and what I'm seeing. You know that this thing means that R is directly proportional to u squared. Is it not true? It simply means that every time I talk about range, I'm talking about initial velocity 2 times. Is it not true? So let me just put it. So which means that if I'm talking about 2R, it simply means 2. Then I have u squared. Or let me not confuse you, let's just do this way. It simply means that I have 2u squared. Do you agree? Yeah. I have R equals to u squared, Shelly? Yeah. So I now have 2. Normally, we know that range is equal to u squared sine 2 theta over g, Shelly? Yeah. So normally, that's why I like physics. R is going to the center and say, the u square given to me there is what? 100. I take the square, then I do sine 2 45, Shelly? All over. I can use g to 10 or 9 for 8. So 10. Now, if I do 100 square, what do I have? 10,000. Are you sure? Yes. R is equals Now, 2 times 45 is what? So sin 90. Okay, all over 10. But what for me? Sin 90, do you remember our approach? It's what actually? Okay, so I have 10,000 times 1 all over 10. R equals to. Now, that means that this can easily cancel with 0. So that means that R is equal to what? 1,000. And remember that this is in meters, is it not true? But this is when we are just using 1 R, is it not true? So you can say 2R. 2R. What this simply means is that I will double this my range. But let's do it together. Can I tell you? So remember they said when the range is double, that's the question now. Find V. We should find U. So let's find the bits now. So this one that we saw is when we have just one range. So let's say R, 2R now will be equals to, we have U squared sin 2 theta, is it not true? All over G. I am. So if I put it together, I already have 2 into 1,000. Is it not good? Equals to U squared sin 2. What angle was given to? What thing that was given to? 45 degrees. Then all over 10. So I can easily say. Calm down, relax. Let's see this way. We solve your method, we solve my method. So let's do this now. Useless and tutor. If G cross over, what am I having? Okay, so I have 2,000 equals to U squared sin 2 into 45 all over 10. This is your method. Yes. So now, all over 1 cross multiply. We have 2,000 times 10, shall we? No. Equals to use. You don't even know which one is U squared sin 2 into 45 is what? Okay. Now I have sin 8 is what? Wow. So I have U squared times 1, shall we? Yes. This is equal to U squared. So it's equal to what? Okay. We now have 20,000, shall we? Yes. Okay, 20,000. Alright, let's take the square root of both sides. 1 4. 4 2. Yeah. This is the bigger pair. But let's do my method. What's not my method? You should be in my class. I have, at this point I say R is equal to U squared, shall we? Yes. And I'll say, when I'm talking about 2R, I should be having 2U squared. Is it not true? Yeah. Yes. Okay. Let me pull it out this way. I'm seeing U squared this side, I'm seeing 2U squared this side. And I'm seeing R, I'm seeing 2R this side. Is it not true? So let's say I have U squared equals to 2U squared. If I take square root of both sides, I have this cancelling is 0. So I now have U is equals to root 2U. Is it not true? Yes. Shall we? Yes. Now, it's at this junction, I will now employ the formula. So I'm now going to have, instead of U squared, I will now have root 2 times U. Then sin 2 theta, which is 45, shall we? Calm down. It was 1, not 1. Not over 10. Not over 10. Then, what did you give us as our U in the first place? 100, shall we? Let me put 100 here. Okay. But this for me. Calm down. This is going to give me 1, shall we? So I'm going to be having I remember the unit was because I'm going to be having root 2 times 100 times 1. Shall we? All over 10. Is it true?
Yes.
Apart from it. 14.1. 14.1. Are you sure? Yes. Check it again. This was the But when I did this, just like this, you can't put in the 900. Are you sure?
Yes.
Mbadu, root 2 times 100, what do you have?
No, that's the without 90 over 10.
Okay, that's.
Yes.
Okay, without even putting this.
Yes.
It's impossible. So, see, I saw this thing using the normal method. Then there's something that called reading ahead. So as I was trying to read ahead, I was trying to discover a method to it. So you see, somehow, it works. Just that I'm not taking time to master it. So the simple thing is that when they give me a response to this, I can actually equate it. Everything on the particular side, everything on the particular side. So when I have made this solid on the formula, this is supposed to be this, this is supposed to be this. I think that's what we have here. And it should work. So my problem is that after getting this, I still need to split up again. Using your own method. So it should work. And you see that that man always make it simple. See, you see that first method? Yes, no, see, you see that first method is normal arithmetics. Like, see, using the normal method that we used to get this answer, it's more or less common reasoning, common sense, it's normal. Yes, you will definitely get the range, then you double the value of the range equals to the formula, you get the answer. But now, when you want to test it, reading ahead, if you use the constants, forget the fact that we made a mistake, you see that this thing proves if you are right or wrong. Okay, this one. See, now we have, naturally, every time we hear the range is impossible in this situation. Now, if we let's say 2 double of range, it's going to be impossible to use question. Now, notice that one range and 2 are, notice, we are comparing. And the same value that this one gave us is what this one gave us inside. See now the thing. So it's not like we pull the answers we have on it side to side. That is u squared equals 1 and double it. When is 1 range? And then when is 2 range? This is what I'm having. So trying to make use of them on the formula.
No, sorry.
No, see, I'm having u squared now, and I'm having 2 u squared. We want to get u. We want to get the u. So that is why we then take the square root of both sides. Remember, this is a math method. Take square root of both sides. It's supposed to make things easy for us. So square root of both sides, this will cancel this. Then the root 2 will remain. Why the u squared? This is exactly as saying root 2, then root u squared. I say this. If you guys this, it will give you this now. No, 2r equals to 2u squared. No, now, you are refusing to understand it. See, let me tell you, what else we are laughing about this thing, Do you know why we are laughing about it? It's because I discovered it too. But if you take them and go over it, you see that it's actually true. Okay. Yes, that's this part. Shall we? Yes, we're not supposed to add this. It's not here. Yes. So that's the problem. This is the problem. Because doing this thing this way, simply this way, going back to your method. So this is actually correct. That's how we should. Okay, when the velocity is double, instead of when the rate is double, we can still do it now. Let's do it.
Yes.
Well, let's see. If I have the same principle, so this one we are using the money to do this one. See, the last Yes. See, we have R. See, R is U squared, Shelly. Is it not true? Is equals to U squared. Now, when the velocity is double, the simply meaning R is now equals to 2U squared. Is it not true? Yes. So if I have this now, it simply means that if I want to now get the range, I will now say at this point, if I take the square of both sides, because nothing like this is less than say 2U, U is being double, it's the initial velocity, the velocity that is being double. Is it not true? Yes. So R is equal to U squared, naturally. And if the velocity is doubled, if we try your method to work, it will give us the same answer. But if we use this one, it will give us the answer faster. So I have, if the velocity is doubled, so I now have 2U. So I carry down my 2U, it's no longer just 1U. For this, we don't think that this is 1U. So I'm talking about H squared. So if I say the velocity is now doubled, it's now 2U. I can't even put here. So by the time I make this to now correspond with this, you see that I now have 2 times this is what? 4. Then this one will come U squared, see how to? Is equals to R. So it simply means that if R is equals to U squared, the range will be 4 times double or quadruple. That's what it means. It's not confusing. See, well, let's use our normal method to do it. Let's see. If we have U squared is equals to R, and remembering that we are carrying initial velocity and doubling it, since I said double velocity, if I carry it and put it there, remember what range is. By the time I do it properly, you will see that since this will now give me 4, and this one now will give me U squared, we'll now remember that U squared actually means range. Which means, okay, let's solve this one method. Let's see. So, but remember the one method. I asked. We've already tried this one, Shelly. No. Okay, that's why you feel it's work on that one method. But this next I will just try now. When it's double. When we say the velocity is double. There is no scientific that given to us there now. Notice, so Shelly, the question you are giving me now. If we have R to the equals to U squared sine 2 theta over G. Notice that we are not giving anything like 100 or theta here. Is it not good? We are not giving that now. So the only thing I should be comparing to is just this and this. I'm not giving any of these values according to what you asked. So if you didn't check it, you see that that one method, if you learn it because it's a normal method, it will be more faster. So I'm not giving sine 2 theta. I know that G is a constant here, but I'm not giving. So I will simply say, naturally, R here is equal to U squared. Is it not true? Now, what you're asking is if the velocity is doubled, what will the range? So let's say I carry 2U now and come here to be equals to my R. And I know that U squared does, U alone does not do anything with range. So if that is the case, I have a double velocity in this case, no longer can happen this way. So raise to power 2. That means everything here is for range, but when it's being doubled, when the initial velocity is being doubled. So when I take the squared, I'm going to have my 4. Then I have my U squared. So I'm now comparing this to the U squared for R. So in the case where it's doubled, I have 4 of this. Unless how we can solve this is, let's say we are using the same parameters given to us for the other question. That is taking theta to be 45. Is it not true? Taking the other values. Now let's check what answer we have. But then our common sense method is going to definitely give us an answer. So this one is more important. That's solving it using common sense will always give us an answer when we have the formula. But this one tests your logical reasoning. And that's why you do this one advanced. At a point, if you not even master it well, you might be confused, which is what happened to us. Okay, let's try. Let's see, we have R equals to the first place we are saying this to be 100 actually. Square sine 2 into 45 all over 10. Okay. Yes. Remember, we want to get velocity, Shelly. There's the when velocity is doubled. What will the range? See now what you ask? Okay. So now let's do. This will give me R equals to. Is Is it 10,000? Okay. Then sign, this is 90, shall we? This is times 1. All over 10. So you see, I'm left with the same thing. R is equal to what? 1,000. Okay. Now, when is doubled? So instead of 2R, now we are using 2U squared. So instead of putting 2R here, like we did the other time, we're now doing R equals to 2U, and this is going to be squared, shall we? Then sine 245. Is it not 3? Okay. All over 10. Okay. So we now have R to be equals to 1. Remember, we are looking for the velocity, shall we? So I will have my 2U squared sine 2. Okay, this is 90. I know. We are trying to show you now. Before you know it, some of you will start saying that you are confused again. All over 10. Okay, which means that this is going to be R is equals to okay, then R, shall we? Is equals to 2U squared. I remember that this 2U squared, that we're using this 10R, we use 45, shall we? Yes, so at angle 45, my new velocity will simply be 2U squared equals to 10R. So this is when a good value is given to me. It is different from find new velocity when range is double, or find range when U is double. So this question now does not even make sense. But if you check it, you cannot have 10R equals to 2U squared. R should be on this code. Is it not R we are finding? Range should have a value. Range should have a value. Range should have a value. No, now what? When we are finding U, shall we? When this is double, is it not good? When we are finding U, when the initial velocity is double, what is it that you are finding? So you see, people are confusing me. See, if we are finding it and we carry 1,000 and put here for range, we're not going to find range now. If I'm finding range when U is double, using this approach of sign, this whatever you say we should use is not possible. So what we can find is when U is double, what will be the new velocity? That's actually what we should be talking about. And that is what we should do in this. But if we really want to find range, when U is double, see, you are not understanding because you don't understand it. Because I am trying to answer whatever question you bring. There are some questions that are not possible. Yes, there are some questions that are not possible. So, I'm finding that because I'm trying to answer whichever one you bring. So, let's say we are finding the question 10 into 1,000 equals to 2U squared, shall we? And I cannot say, if this gives me 10,000, I'll have U squared over 2, all over 2. This will cancel me, is it not to 5,000? I have 5,000 equals to U squared, shall we? And square both sides. So I have what?
70.71.
This is what is apparent to their value. So all those your imagination, you will be giving it to load. So that we can do what we have today. Imagination below. Yes. You know the most part. Why I'm used to answering all questions because I know the physics. But sometimes when you start asking so many questions, as if you don't know it. Yes. So this question now, this particular one, it's not possible. What we should be thinking of is if initial velocity is double, what would we do? And I think those are going to work it out. That's just what we do. Alright, so give me 132. I think that's I am what did I ask there?
You understand it now? So, and you see that you're moving the angles.
You know that what we are doing here is brain muscle. You are cracking your brain as you are learning. It's not every time that you are just meant to be sitting there without thinking. You want everybody to be thinking. Somebody will say, "Stop this, next one, next one." If we don't know those things here, do you think it's that what you want to be doing it? Yeah. What can you give me?
If A equals 3,
If A equals 2,
4I plus 3J.
wait, if A equals 2,
No, if A equals 4I plus 3J.
4I plus 3J.
I plus 5K.
And then,
And B equals I plus B plus K.
and B equals I plus
A plus B.
and
What are A plus B and A minus B?
okay, what are
A
minus okay. Alright, so please let's look at this very well. You know that once we have I and J, we are talking about vectors, is it not true? And we know that this stands for X. This stands for Y, is it not true? This one stands for Z. And remember when we started, I told you that there's something called magnitude, is it not true? And I told you that once you are doing magnitude, the eyes will leave. Is it not true? Which means that we are not even going to be thinking of magnitude when we are doing I, J, K, when we are adding or subtracting. We also talked about Pythagoras. I will say that Pythagoras is used to actually find the resultant. Let's say I have everything for X, I have everything for Y. Is it not true? We talk about Pythagoras. So which means that since I have I, J, K, Pythagoras is not supposed to work here. Is it not true? So please, why am I putting this? So that you see that all the available things you want to think of is gone. So we'll just add this up normal. So I'll say A plus B is going to be equals to bring all the I one side. 4 plus, you know that this thing means 1, isn't that true? So plus 3J plus J. So minus 5K plus K. Alright, so please, why we first started with deleting all those options that will come to your mind is that there are people that imagine too much. Once you see this, you are thinking of the next thing to do. You will say doing addition like this is very common. No, this is what we're supposed to do. So 4I plus I is what? I. 3J plus J is what? 4J. Minus what you see. I think what let's put ourselves inside of it. Oh, you know that this is the same as saying see, this is the same as saying plus minus. Okay, no. Minus 5K plus K is what? Minus 4K. Alright. So A plus B, what do A minus B for? So please, let's do it together. A minus B is going to be the same as saying, let me use here for those of you on that. So I have A minus B is equals to 4I minus I plus 3J minus J. Yes. So plus minus 5K minus K. So this is what I'm doing. See that because it's minus, even though it's minus, notice that I'm doing the subtraction, but I'm still adding I've seen so many positives and plus I've seen those signs. Okay, so you don't confuse it. 4i minus I. Then I have minus 5k minus this. Is this what it was? Yes. Okay, so this is my final. Very simple. And give me the next 133 naturally. Please, let's try to be fast. This is not going to do. Maybe we'll finish with this workbook once we enter our physics manual. Yes. Please, then, if possible, let's try and do something. We'll pick some questions there that are one kind from that manual, the last manual. Even though those ones are telling you to find mass, get the edge, small and big edge. Let's just do it and go. I see. What else did you give me? This is 7 fundamental. Okay, so I know that we have mass. Is it not true? We have length. We have time. We have energy current. Is it not true? We have luminous intensity. We have temperature. We have temperature. We have luminous intensity. And we have amount of substance which is mole. And remember I told you that all these fundamental quantities are all scalar quantities. Which is why you cannot come and tell somebody, I am feeling hot in northwest direction. Can you tell somebody I am feeling hot in northwest direction? Yes. Is it possible? Yes. The person will say you have gone, it's not possible. Or you say, my pot of food is in southwest direction. It's not possible, huh? It's not possible. You think that kind of distinction, the person looking at you will play anywhere. So all the 7 fundamental quantities are scalar quantities. Alright, so we have that for that. So I give you the next one.
If a body is moved by force of 40 minutes.
But please, can you present? If a body, you know one thing you must understand about this class. If you are participating, if you are someone that is participating since we started this class actively, you will see that you will be following well. Because you are part of the class. You are teaching yourself as you are learning. But some of you are waiting for others to be doing the work. You need to be participating. That's the key thing in this class. Participate. So, when I give you 134, Jamie?
Yes.
What give you?
If a body is moved by the force of 40 minutes.
If a body is moved by a force of 14
causing the body to experience the velocity.
Causing the body
To experience the velocity.
to experience velocity, yes,
Of 2 meters per second.
of 2 meters per second, yes.
What is the power exerted on the body?
What is the power?
Exerted on the body.
What is the power exerted on the body? Okay. So that is what we are looking for here is power.
Yes.
Even though we've not looked at power, but we know we come across this one with dimension, units and dimension. So we normally say that power is the rate of work done. If somebody, if I say on your mass, run from here to Hobby, believe me, somebody will come first. Is it not true? If I say now everybody line up on your mass run, somebody must come first, get to Hobby. That means that person has running power than every other person. I say, so if somebody is able to cover or do something at a short space of time or at a lesser time, that person is said to have more power. So somebody that is faster than you or that can produce or actually do something in a less or in a shorter period of time is considered to have more power. So if you know that we say that power, even in second semester, all utility resistance and current is equal to power. And also, power is equal to work done. And then work done is equal to Displacement, please. How is this displacement for me? Oh, yes. Yes. That's the right thing to say. It's just that it's popular. Most people are popular with saying first, work done equals the first times distance. But always use it. They are the same thing though. Should I told you? But always use that one. So, for example, what I mean is, if you come here now, you are pushing this thing, is not moving. You've not done any work. I see it. But if I'm pushing this thing is moving, it has direction. Anybody that comes will say, okay, he did something. He was able to push this thing from here to this place. So always use that displacement for me. Alright, and now over T. Now look at this thing, it looks like velocity. Shall we? It means that this is also the same as the with this we have our answer. Now the only thing I want us to be doing in this physics, for us to really remember, in as much as sometimes we try to look as if it's funny. You see that man method? When you go home, relax. When you go home, as you read and read and read, when you read too much, do you know what comes with it? You now start trying to invent your own things. That's what I'm trying to say. So the minute you now start to go ahead to invent your own things, you will see that it will be retained, the knowledge will be there extra. So please, as we've done this one, especially of the things we are doing to, when you go home, start trying to think, what other ways can you do this thing? What other ways can you do this? By the time you still start doing it, you see that you'll be enjoying it. Yes. It will be there. Anytime you wake you up, you'll be able to realize. So they gave me first 40 minutes training. Then velocity, they gave me velocity 2 meters. And 2. One from me, what do you have? 80 watts. And you know, when we did units and dimension, we treated this. And what I want you to do for me when you get with this assignment, there is assignment I gave you on dynamics. Are you with it? Now I tell you to exercise and tips. Is it next week I said? Okay, on Saturday. Please, if your one is not open, check this. Please, Saturday next week to submit it. Yes, that dynamics assignment. Now, please, when you get on, add this to it. Find me what 1 horsepower is equivalent to 1. You will show me with proof. Then you will not see, you will not find me what 1 joules is in watts. Yes. So that's the second to your different. Give me the next question. What can you find, Shani? Measure pressure. There are plenty of them. Plenty. Maybe if you start reading your notes or maybe research, you say a lot of things. There are plenty. But I know that these two are very common. Yes. So especially this one. Yes. So plenty of it. So when we start doing rotational motion and dynamic motion, you look at that one. Alright, can I clean? I can clean, and I can clean this thing. So the next question, look at the 6. And give me. Do you know what you must understand? Before I come here to start and solve a workbook, there is an information I've got which I will not give you. But as things start to unfold, you see the reason why I rushed to that place. When some of you were complaining the last time, the lecturer said they would do quiz with workbook. We focused on solving 1 to 30, or is it 30? Yes, Jerry? And that was what he gave you. Today we are doing 130 and we need to see that we finish everything from 130 to the last page of that one. Yes. So when you start to see the plans, you will still remember. 136 or is it 135?
I almost agree that.
Okay, one calm down, that's the noise. Define angular displacement. What? Do you remember when I told you that last week that I was writing something like this? Yeah, come and put, if this is radius how, this one is radius how, and I said that this one is still like 0 to, and I said that something like this is displacement. Or this one is 0 to. Please, angular displacement is this one. It's represented with theta. Are you seeing it? Yes. And we normally say that angular displacement is simply the ratio of arc distance to radius. So we normally say that angular displacement is the ratio of arc distance, we say arc displacement to radius. So we can say that this is theta equals to S over R. Very important. Yes. So you can say it's the ratio of arc displacement, or you say arc length to radius. So it's important you know theta so that you also know the definition for it when it has to do with the formula, setting up the formula. So I said it is the ratio of arc displacement, or you say arc distance to radius. Very important. Last week we derived, even progressing with this, we still remember how we derive our velocity and the rest of it. It is a together acceleration. Alright, then the next question is what? That's what now? Okay, what is that? What's he saying? The unit of measurement of angular acceleration. Okay, angular acceleration. Okay, in most books you see it as rats per second square. I say it. So, but the normal way to pronounce it is simply, the unit is simply radians per second square. And that is where from next week, everything we are going to be speaking of is just circular motion, rotational motion, dynamics of rotational motion, rigid bodies. So from next week we are now moving from, it's no longer going to be linear, now we're going to be doing angle. So radius per second square. I give you the next question. What text was now? Okay, what text is the study of what? Of motion. Without regards to the force that causes it, it's kinematics now. Some people, if you see, read the explanation, and she would have corrected me. Kinematics. So I call it kinematics. Yes. So we say that this is simply in some economic term and students regard this as the equations of motion. It talks about the equations of motion. So it is the study of motion without respect or without recourse to the force causing motion. But if we are talking about the study of motion with respect to the force causing it, what is that? So yes, and I told you that dynamics in summary, we can just regard it as the laws of motion. Yes, it's under this one you now start to get as a new to set, as a new to set. Yes. But I give you the next question. Okay, 3 examples of projectile motion. Okay, you know your javelin, your secondary ship definition, and your short put sailing, and a launch ball. So there are so many of these kind of questions are ones that you are doing research. So many of these. Alright, even somebody throwing a basketball, that type of case is a case where you are launching from the height. See that case? I'm giving you all the cases of projectile. If you've been following my classes, it's not to make maths. But if you've been following our classes gradually, like step by step, each class, I believe you will have no leakage in physics. Unless you just say that you do not check their notes. Check their notes. And have it in mind that if you just started, you did not miss anything. We are going to be starting batch A, batch B, and batch C class. So once we start batch A, batch B, batch C class, batch C will be next year. If you hear batch, B means people that started late. Join the late comers if you do not start on time. Don't come and say you want to be A. Everything about you is that A is for good thing. Yes. When you have to do with batch B, join batch B so that you cover all the things you miss. Alright, give me the next one. What text meaning now? Okay. That means this one is supposed to be 139. Okay, this one is examples of projectile motion. 139. But give me 140 is what? Okay. Mathematical representation of maximum height. See how good? simply equals to, okay, let's derive it from our first mathematical it's very good as my script is just as science script. Are you aware? Yeah. I give you the next one. Center of what? Okay, we can say the center of mass is simply the area that appears to have more concentration of a body. The area that appears to have more concentration of a body or of the mass of an object. I said it is the area that appears to have more concentration of a body or the mass of an object. We can say it is the area that appears to have more concentration of the body or of the mass of an object. How are you concerned? You are one of the people that started this tutorial, but we don't see you. How many people don't tutorial with us? What's on our first level? Why did I fail us first? One person goes to job. You know that's one of the things about this school. When you enter the year one, you know what you want. Is it not true? Because you don't have friends. Before you get to start having friends, yes. Before your mind will not start telling you, take it slow. If it happens, well, no problem. If it doesn't happen, well, no problem. But guess what? When you think that way, it will definitely not happen well. Yes, because it will not be happening average. Yes. People that get it first class, that get it first, they are people that are always serious about it. Any small thing they are scared, like they are afraid that something bad will happen. And they can't fear, they will be correcting all the problems. But I say those ones that will say, let me relax more, nothing will happen. Anyhow, when it comes out, no problem. Those people will always come out average. It's normal. You see those people copying some questions inside class. And one of the things that happen is, even if you like copy, if you have 30 questions, you copy the whole 30 questions, the solution to the 30 questions. Guess what? You will still not come out well, like somebody that wrote that thing with his head. I wrote it perfectly. That's why you see some people, when it gets to all those called BD, ordinary differential equation, here you will see x, y everywhere, x, y everywhere. And one y you miss, you might carry y and put before x. It's not the same thing. When they come and see that they failed it, yes, you know what people will be doing ODE in your 200 level. And this course is something master will be teaching you. So you notice that by that time you will see plenty x. All you the engineering students are doing it now. In one. So first semester engineering students do it as fair. 200 level people will do it. Not the medical students. So I have done for center of mass. Okay, I said it is the area that appears, or the area that appears to have the concentration, the most concentration of the body, or the mass of an object. Another way to define it, another way to define center of mass is simply the area or the position which other parts of the object tends to. The position which other parts of an object tends to. That's what we call center of mass. The position which other parts of an object tend to. Alright, question what's now? 142. We are fast. I give you 142 volts. You just define center of. Okay, center of gravity. Okay, we can say that center of gravity. The only difference between center of gravity and center of mass is that center of mass has to do with mass. Is it not to be? Why center of gravity deals with weight? So we can define center of gravity as saying the area or the position or the points where the weight of a body tends to. Yes, the position, the point, the area that the center of a body is directed to. area, the position, the point, whichever way you want to elaborate it, that the weight of the body is directed to the center of gravity. I will know that the gravity of the body, the center of gravity of the body is directed towards what? Is it the center? Yes. Are you sure? I would prefer you say it's directed downwards. I would prefer you say downwards. And you will see some questions that will ask you, why is the center of gravity for the earth considered to be negative? It's simply because the center of gravity of the earth is considered to be downwards. And we know that anything downwards, what we are dealing with vertical, is negative. Is it not? This part is positive. So you see some questions that will ask you. So the best way to put it is that the center of gravity of the body is directed downwards. Center is okay, but downwards is much more correct. Yes. So then I ask you, why is it negative? It's considered negative because it is going downwards in vertical axis. And we know that anything vertical axis downwards is negative. Alright, so give me the next one. Calculate the question what now? 1 calculate the time. The time taking for a mango tree. Okay, mango fruit. And that falls from the tree, yes? 20 meters to reach the ground. Okay, ground. So the answer that G is equal to what? Check. It's correct. The answer is correct. Okay, calculate the time taking. Okay, you've already solved it. Okay, you got 2 seconds. Yeah, I like that. So we think S is equal to somebody is saying answer. The friend is telling him the two one. You don't want him to express himself. He's correct. He might be correct. So when a body is falling down, the initial velocity is what? Why? Because it's giving. Because it's coming to rest. Because it's falling down. So let me tell you now so you understand. Physics is not imagination. See, when this body, since the body is falling down, that means it first of all went up, is it not? So which means that when it was going up, it has initial velocity, is it not? Since it's now coming down, how can they go initial stage? One is the ending stage, is it not? So at that point, it will no longer have initial velocity. Here it wasn't good. I see the first final velocity. So that is why we normally say that when something is going up, it has initial velocity. It's coming down, it has final velocity. And we say that something that is going up, since it's still moving out, that at this point, U will be 0. When it gets to maximum velocity, it will stop moving. So that's what happens to the U. Alright, so I'll have 0 here. 0 times T, this will get out. I see it. So I'm left with S equals to half GT squared. And you know why my half GT squared is positive? Because it's coming downwards, you mean? So it's obeying. So now, S theta is 20 equals to half M T squared, you mean? Okay. I have this to be 10T squared over 2. That's easy. 20 over 1. So cross multiply, you have what? You have 4 to equals to 10 T squared. So if we divide both sides by 10 until you're full of here, I am not confusing you. How can I confusing you? Okay, the day of I watch. I have here the 20 for this displacement, which is this 20. As in from the 3 20 meters. They did not tell me displacement, but I know it's displacement because I'm seeing meter. So the TF for this S. Then I'm saying this one is out because now U is 0. And anything times 0 is 0. Wait a minute, no use. Then I'm not having loss. Okay, I want to have that. So then I have half. Then G to 10 because they're getting G equals to 10. So I put it. Then this when you have a formula for the equations of motion, I will still post it today. So you see the three equations of motion and how to derive it. So here can you see, since I have this one 10 times half, about 10 t squared plus multiply, you will say 20 times 2 equals to 10 t squared. So here inside you will get 40. So when I say divide both sides by the coefficient of t squared, which is 10. So guys can cancel on that. So I'm left with t squared is equal to what? 4. If we take square root of both sides, this will get out. So I have t is equal to what? And the limit of time is what? So what did I define unit as? Define unit, what is unit? Notice that each time we are solving this manual, it's helping us do revision. Are you aware? Yes. So what is unit? Define unit. A standard for comparing or expressing physical quantities. Very important. A standard for comparing, even measuring or expressing physical quantities. Man will be able to say, give me 20. Is it 20 again? But the minute the person says 20 kg, you know he's talking about mass. Is it not true? And another name for mass is apparent weight. Is it not true? If the person says 20 in naira, you know he's talking about money. If the person come and say, give me 20 kg, the person is talking about temperature. So that's yes, that person is asking you for very cold Pepsi. That's it, man. Yes, that person is telling you degree that is that. Yes, and I give you the next one. I ask. See how your question always go. This is that. You ask it once, you leave me to answer it. I ask. Yes. Well, see, yes. Let's do this way. See, I have this with the y-axis, shall we? And I have this with the negative y, and I have this with the positive y. Let's say this is the x. Is it out there? Now, please pay attention. If we are talking about the x now, and we are focusing on gravity is what we are talking about. It is always standing downwards and it's going on the negative side. So F gravity is negative. That is good. So naturally, anytime you talk about gravity, it's a negative focus on Earth, on downward. But when you now say that something is moving in respect to gravity, what you are now checking is it obeying gravity or is it disobeying gravity? So when that thing is moving the same way that gravity moves, it is positive to gravity. It adheres to gravity. But if it's moving against means minus. So if it's moving upward with respect to gravity, it's like it's moving against gravity. That is why we normally say a body moving downwards is having plus G. While the one moving upward is having minus G. But when you are talking about gravity with respect to X, on the axis of vertical and horizontal, it moves downward. Well, give me the next one. Question what now? 1 4. I am 1 4 4. What's it? Pay attention though. Where you go there? Okay. Close hand. On a smooth. Hey, calm down. Stop touching. On a smooth level ground head. Level ground head. Okay, smooth level. Okay, the motion of each center is. Okay, they don't give us. Okay, the motion of each center is dash. Okay, but let me tell you.